Again, it's a red stick.
What is going on, guys? Welcome to the fourth episode of the C++ tutorial series. In today's video, we're going to talk about variables and data types. So let us get right into it. All right, so as always, let's start with the code structure first. We're going to say include IOStream, and then we're going to define our main function here, return 0. And before we get into variables and data types, one thing that I wanted to show you is that you can also use the whole std namespace that we used in the last video. So what we did is we said std cout and then hello world and std endline. This is what we did. What we can also do, if you don't want to always specify that std namespace in front of every function or tag or whatever you're using out of it, you can go ahead and say using namespace std. And then you can just get rid of those std prefixes here. However, why didn't I show it to you in the first video is because I don't think that you should get used to that way of programming, because using namespace std and then just writing cout and endline and so on is not considered to be best practice. I mean, of course, you don't always have to code in best practice, and it works. You can definitely go ahead and write code like that. But if you're going to write clean C++ code, you're not going to do it like that. Because first of all, you're just using cout and endline from std right now, and it doesn't make sense to use the whole namespace because of that. If you're only using cout, endline, maybe one or two other things, it doesn't make a lot of sense to use the whole namespace, to just include or import or whatever, to just specify that you're using the whole namespace, because it's just too much, so to say. It's not clean. It works, it doesn't have any problems, it doesn't bring any problems into your program yet, unless you have a second namespace that also has something like cout or endline, because then you run into some problems. But it's just not the general accepted best practice way to say using namespace std and then cout and endline. You're always going to see this in code examples because it's just more convenient. And if you're doing some videos, if you're writing a blog post, if you're just practicing, if you're just writing some sample code, you can definitely do it like that. And we can also definitely do it like that in the tutorial series here. I'm not going to do it like that, but we can do it because it's not wrong. But I don't want you to get used to that way of programming, so we're not going to do it like that. I wanted to show it to you that it's possible, but we're going to write the best practice type of code here. We're going to always specify std before we use something from that namespace. So that's just something that I want to show you before we get into variables. All right, so let's talk about variables now. Variables are essentially just placeholders for values in programs. So maybe variables from mathematics already. They're just stuff like x equals 10, or y is a function, or y is some list or some set or anything in mathematics. And it's the same way in programming, just that we have a lot more data types. We have integers, so whole numbers. We have floating point numbers. We have Boolean values. You have text values. You have lists and collections and structures. And later on, even objects, whole objects that represent stuff like a person, for example, can be stored in a variable. And in contrast to languages like Python, for example, C++ is statically typed, which means that we have to specify the data type of a variable before we can actually assign a value to it. In Python, for example, for those of you who know Python, you know that you just go ahead and say a equals 10, and then the interpreter already knows that a is going to be an integer for now. And later on, you can also say a equals something else, like hello. So hello is a text, so a is no longer an integer, a is a so-called string. And in Python this works. In C++ we don't do things like that. In C++ what we do is we specify the data type first. And if you want to have an integer, you specify the keyword for the integer, which is int, and then you specify the variable name. So you say int x, for example, int x equals, and then you can say int x equals 10. And if you want to change the value of x, what you do is you just say x equals 90. Again, don't forget the semicolon for those who are used to Python. And you can change the value as many times as you want, of course. You can say x equals 20, x equals 90, but you cannot change the data type. You cannot just go ahead and say x equals hello, because then the compiler will tell you that this type is not compatible. You have an integer and you want to assign something else to it. This is not an integer here. You want to assign a string or something else, but it's not an integer. It's not compatible. So this is statically typed. You have to specify the data type first, and then you can assign a value to it. So that's not too complicated, but let us now go ahead and talk about the different data types. And we're going to talk only about the primitive data types now. This means just basic stuff like numbers and texts and Boolean values, and not stuff like lists or structures or classes and objects. So just the primitive data types here. And we're going to subdivide them into three categories. First of all, the numerical data types. Second of all, the textual data types. By the way, these are just my terms, so maybe they're not 100% scientifically accurate. And then we have the Boolean. Okay, so the numerical data types are essentially you have either whole numbers or floating point numbers. But there you also have different types of floating point and different types of whole numbers. So you have the integer. This is the basic one that we saw already. Int I equals 10, for example. But then you also have the short and the long. And the short and the long are actually just integers. In fact, you don't even have to say just short. You can say short s equals something. But you can also say short int s equals something. And that's actually the same thing, because short is just another type of integer, and the only difference is the memory value or the memory amount that they occupy. Now this is something that you never worried about in Python, because in Python you just, you define stuff and it happens. In C++ we're operating on a lower level, and this means that we need to care about stuff like memory management. We need to know, do I really need an integer, or is a short enough maybe? The difference, of course, is that they occupy a different amount of bytes. So we can actually look at how many bytes they occupy by using the sizeof function. So we're going to say std cout, and then we're going to say integer int. So this is just some text. You can write whatever you want in here. And then you say size of int, and then maybe an end line in the end. So what this function is going to give you here is it's going to give you how many bytes an integer occupies in the RAM, in the memory. And we can go ahead and open up a new terminal and compile this main.cpp, main.exe, and then we can go ahead and run main.exe, and you can see that we get 4. This is 4 bytes, and a byte is 8-bit. I'm not going to explain the binary system to you, but if you know the binary system, you have essentially 1 byte being 8-bit, which means that 4 bytes are 4 times 8 bits, which is 32 bits. It's quite a large number, and we can go ahead and do the same thing here for the short, and you're going to see that a short occupies less amount of memory. So we can say short size of short. You can also say short int, it doesn't matter. And then we compile it again and run it again. And you can see a short only occupies 8 bytes. We can do the same thing for long as well, and there you will notice something that's quite interesting. And it is that in C and C++, oftentimes things are just not defined. Now in this case, in my computer, it's going to say that a long also has 4 bytes. It doesn't have to be that way on your system. The definition for a long is only that it has at least as many bytes as an integer. Doesn't mean that it has to have more. It can have more, but it has to have at least as many. So maybe in your computer it's going to have 8. Maybe it's just going to have 4. It doesn't matter. It's not defined, and we'll encounter many things in C and C++ that are not defined, that are undefined. We don't know what's going to happen when we do them. They're not forbidden, we just don't know what's going to happen. And this is also one of those, we don't know what size of long will return on every system. So what does that even mean? What does it mean that a short has 2 bytes and an integer has 4 bytes? For this, we're going to open up the Windows calculator. So just open up your calculator and set it to programmer mode. And then we can talk a little bit about the binary system. We're not going to explain the whole binary system. So if you're not familiar with it, you can just ignore this part or just watch it and accept it as the truth. But essentially, if you have 2 times 8 bits, so 2 bytes, 2 times 8 bits, you have 16 bits. And 16 bits means that you have 16 zeros and ones that you can set, which means that you have a certain range of values that you can use for this short. So for example, if I set all the values, so all the individual bits, all the 16 bits to true, I would have 1, 1, 1, 1, this is 4, then we have 8, then we have 12, and then we have 16. So this would be 16 bits set to 1. And if you convert this number to decimal, you can see that that is the number. That is the maximum number that we can represent using 16 bits, using 2 bytes. Now we can go ahead and copy that number, and we can say short as equals that number without that here. And we can go ahead and print it, but you're going to notice an odd thing here. So I'm going to say actually just s itself, end line. You're going to notice something that's a little bit odd here. It's going to not work the way we want it to work because it's going to give us -1. And even if we decrease it or increase it, it's not going to give us what we want. And this is because we're not using a so-called unsigned short. The difference between a signed and an unsigned short is that if you have a signed number, like that, this is the default, we don't need to specify, but if it's signed, this means that we start at 0 and we go into the positive direction and into the negative direction half as many bits as we can, so to say. So instead of using the numbers 0 to that maximum number here, what we do is we go from 0 to half that number and from 0 to negative half that number. I hope this is not too confusing. If we want to use all the 16 bits only for positive numbers in C++, what we do is we say unsigned short. Because by doing that, we can use a full range from 0 to 65,535. So we can go ahead and compile this, and you can see that we get that value. Now, what happens if I add one more to it? What happens if I go beyond that number and try to add one additional bit? Because in order to represent that number, 16 bits are not enough. We need to add one more bit. What happens if I try this with a short that only has 2 bytes? You can see what happens. Actually, it stops. Actually, this is not what I expected, because usually it gives you an overflow. Oh, it didn't compile, that was the problem. Yeah, as you can see, we get a warning, a compiler warning that says overflow, something with overflow. This means that we're going beyond the limits. This means that we're going beyond the capacity that we have. And instead of saying, no, you cannot do this, it's going to just overflow. So it's going to start counting from the beginning again. So if I run this, where is it? There you go. You can see I get 1 because I surpassed the maximum by 2. If I surpass it by 1, we will get 0. And if I surpass it by 3, so if I say 8 here, we're going to get 2. So it just starts all over again because it doesn't have any capacities. It just has 2 bytes, and if you try to store a number that's too high into it, it's going to overflow. And of course, this can be done for integers as well. We can go ahead and say unsigned int, and we can think about what this means. We have 4 bytes, which is 4 times 8 bits, and instead of doing this in binary, we can just say f. F, as you can see, is 4 ones, so f is 1, or f is half a byte when you're using it in hexadecimal. So we can say f. So we have 2 bytes now, then we have 3 bytes and 4 bytes. So this is the maximum number that can be represented with an unsigned integer. Let's see if that's true. We can say unsigned int equals that number, and we can run the script, the program, always making that mistake. And you can see that this number is represented correctly. And if I go ahead and say 6 here, so 1 more than is allowed, you can see I get a warning here, and we start at 0 all over again. For the long, it's going to be the same on my computer since it's also 4 byte, but what we can do if we really need more, we can go ahead and say long. I'm not going to change the string left here, so just ignore it. But we can go ahead and try a long. This is something that is going to have a little bit more space. As you can see, it has 8 bytes. And we can go ahead and see what 8 bytes are. 8 bytes are essentially 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, the Windows calculator itself gets an overflow because that's too much. It doesn't store anything that's more than just a long. So we're not going to do the same value thing here, but essentially if you really need a lot, you just say long, otherwise integer should be enough for most calculations. But you can see that in C++ we need to worry about that. In Python you can just define any number and it's going to adjust and it's going to allow you to have that number no matter how high it is, how large it is, as long as you have enough memory left in your RAM, of course. But this is something we actually need to take care of in C++. All right, so besides those whole numbers here, we also have floating point numbers, and for those we have the two data types, float and double, whereas the float is less accurate and the double is more accurate. So the double has, I think, 8 bytes, double, and the float has, I think, 4 bytes. And we can see if that's true by just compiling and running. Yeah, as you can see, 4 and 8. And this means that the float stores up to 7 digits of accuracy, and the double, I think, was 15 digits of accuracy. And of course, if you need even more accuracy, what you do is you say long double, and then you have more accuracy. But yeah, this essentially means if you have a number like 16.7 or 16.75, you better store it in a float because it needs less memory. So we can say float f equals 60.78, for example. And if you have a larger number, you say double d equals 90.876512. And if you need even more than that, you just say long double ld equals, I don't know, 9.18675489976, and so on. So depending on the accuracy you need, you choose the floating point value that you want to use. Now, before we get to the next data type category, I would like to show you something. If you want to know the limits, the boundaries of a data type, what you do is you go ahead and include the library limits. So you say include limits.h. And when we have done that, we can we can access the maximum and the minimum values for each data type. So we can go ahead and say std cout, and then we can say int underline max. This is the maximum value for an integer, at least for a signed integer, I think, if I'm not mistaken. Let's see if that's true. And we can go ahead and say std endline. Actually, let's get rid of all of that here. We don't need this anymore. And if we run this here, yeah, it's a signed one. As you can see, it's half the actual maximum. And we can do the same thing for the minimum here. Int min, and it works as well. Now I think we should also have something for the unsigned integer. So uint max std endline, which stands for unsigned integer. And yeah, there you can see the maximum. So if you want to access it real quick, you can do it like that. And I think this should be available for all numerical data types. So short, actually short is not available. Oh, actually shrt max is short. There you go. And it's probably also available for a long. So long max. And as you saw, you also have long max. So we can see what that is. And line. And let's see what we get as an output here. As you can see, this is the maximum value for long int. Great, so let's get into the textual data types. And the first one is the character, the char C or character C. What we do here is we define a character by using a single quotation mark. And this is just one character. It's one character. I think character uses the UTF-8 encoding, which means that 1 byte is enough to represent all the UTF-8 characters. So a character we're going to see has 1 byte. You can go ahead and print that std cout size of character. And when we run this, you will see it has 1 byte, which means 8-bit. Did I say 4-bit? Sorry if I said 4-bit. I mean 8-bit, of course. So this is sufficient to represent all the different UTF-8 characters. And we can go ahead and do it like that. And you can see A, but I think we should also be able to assign a number like 19, for example, and it would typecast it into a character. As you can see, yes, 19 is this character. Something like 80 should probably be a letter. Let's see if that's true. Yeah, as you can see, uppercase P is the UTF-8 code 80, or maybe the ASCII code, but I think character is using UTF-8 encoding here. So a character is just a number that represents a character, okay? That represents a character, and this character has a certain identification number. In this case, 80 is uppercase P, for example. So that's a very simple data type, just has 1 byte, and it represents characters. And now we have another textual data type, which is the string. And a string is actually just a collection of characters. Now, this is a little bit more advanced. You need to know about lists and arrays and so on. But a string is essentially just an array of characters. It's just a C array, a char array, so to say. But we're going to talk about that in a future video. For now, just use the std string, and the string is just a text. The string is a text. It has 24 bytes, I think. So hello world would be a string. And we can go ahead and print this string here. And we can also print its size. I think it should be 24 bytes if I'm not mistaken. So size of string should be 24. Oh, I got an error here. Oh, of course, std string. Yeah, as you see, 24 bytes, and hello world is a text. So whenever you work with text, you're using strings. Individual characters, you use chars. Okay, so last but not least, for the primitive data types, we have the Boolean. The Boolean is also a very simple data type. It also has only 1 byte. And that's actually even too much for it, because the only 2 values that a Boolean can have are either true or false. That's all it has. It's just a truth value, so it's either 1 or 0, true or false. And we can go ahead and define a Boolean with the bool keyword, so bool b equals true, for example. And then we can go ahead and see out that value and line. And you'll see that we get 1. This is important because even though we have the keyword true, a Boolean is just 1 or 0. So we can treat it as a number. Like not necessarily a number that you can do calculations with, but you can check for 0 or 1. You can also define it by saying bool b equals 0. This would be false. And it will also print 0, of course, but it's not all of a sudden an integer, right? It's not just an integer or a short that you can do calculations with. It's 0 or 1. It's a Boolean value. It's true or false. It's also represented as 0 and 1, but it's still true or false. And this is something that we're going to need when we get to conditions, when we get to comparisons, when we want to know if something is true. You know, in programming, you have certain conditions where you can say if something is true, do that, otherwise do that. And the value that this comparison, if something is true, or this statement gets you, is a Boolean value. So when you try to say if the input of the user is valid, this is a Boolean value. The input is valid, true, the input is invalid, false. Or if this number is less than this. And this is also a comparison that gives you a Boolean, which is either true or false. So this is a very important data type. We can also look at the size of it. As I said, it's 1 byte. Not a clear screen. Come on, compile. Main axis, as you can see, 1 byte. By the way, one thing that I didn't mention here is that you can not only get the size of the data type itself, you can also say get the size of b, which will be the same in this case, but sometimes it differs. So you can also get the size of a particular variable. All right, so that's it for today's video. Hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. I tried to cover everything here in as much detail as possible, but also to keep it simple at the same time. So I hope it's not too confusing for those of you who learn programming for the first time. And for those of you who already know Python or Java, I mean, for Java people, it's probably easy. But for those of you who know Python and learn C++ now, the only thing that you need to keep in mind is that in C++ you always need to specify the type. It's statically typed. It's not like Python. You need to say I'm dealing with an integer here, I'm dealing with a string here, and it's going to stay that. Once you define something as an integer, it is an integer. It's not going to be a string later on. Of course, you can do typecasting as well in C++, but typecasting works differently. It's not like in Python where you just say get this input and now I'm all of a sudden a string. It works differently. So keep in mind, C++ is statically typed. It's more strict. You need to care about memory management. You cannot just do whatever you want and trust Python that it's going to take care of it. In C++, you're responsible for your code and the consequences. This is very important. All right, so other than that, make sure you subscribe to this channel and you hit that notification bell to not miss a future video. And other than that, thank you very much for watching. See you in the next video and bye.